The Klang Valley Mass Rapid Transit, or KV-MRT, is a 51-kilometer rail-based public transport that will be the backbone of a new sustainable transport system. Due to their proven track record in tunneling underground, MMC Gamuda KV-MRT Tunneling Sendirian Berhad was awarded the largest work package by the government to design and construct the 9.5-kilometer underground works for the KV-MRT Sungai Buloh Kajang line. The underground tunnel goes from the North Portal in Semantan to the South Portal at Maluri. The tunnel connects 7 underground stations: KL Central or Museum Negara, Pasar Seni, Merdeka, Bukit Bintang, Pasar Rakyat or Tun Razak Exchange, Cochrane and Maluri. The Semantan North Portal is located at the intersection of Jalan Duta and Jalan Semantan. This is where the elevated section of the KV-MRT goes underground. Work started on-site in June 2011. 2 earth pressure balance TBMs were launched in June and July 2013, both heading towards Pasar Seni via the Museum Negara station. The Museum Negara station is located in front of Museum Negara, underneath Jalan Damansara. Work on site started in April 2012. The station box was built using a top-down construction method. The station box walls were constructed using diaphragm walls with ground anchors. The earth was removed until the roof slab. King posts were installed and the roof slab was constructed with access openings for work to proceed downwards. Excavation and construction of the station box then continued beneath the roof slab. The Museum Negara station consists of 2 levels, namely the concourse and platform level. On 24th December 2013, the first earth pressure balance TBM from the Semantan portal broke through the Museum Negara station at the platform level. The second TBM broke through 3 weeks later. As the TBMs were undergoing maintenance works, temporary concrete struts were installed to stabilize the diaphragm wall at the far end of the station box to allow for the base slab to be completed. Once the base slab was done, the concrete struts were removed using a diamond cutter. The area was prepared for both TBMs to be pulled through to the other side of the station box. In March and April 2014, both TBMs were relaunched to continue its drive to Pasar Seni. After both TBMs were successfully relaunched from the station, the truss frames for the TBMs were dismantled. Permanent columns were constructed and the temporary king posts were removed. Backfilling of the roof slab was completed and the station was prepared for the next stage of traffic diversions to allow for the plant room construction. As the TBM mined from Museum Negara to Pasar Seni, it passed by sensitive structures and national heritage buildings, including the old railway station. Extra precautions were taken.
We get to monitor the effects and the impact of our TBM drive, which will be passing by here, on the structures above, on the surface above.
Optical prisms were placed on the train tracks to monitor movement.
We are not able to access to the track all the time, so we use this optical prism instead, where we do not have to actually go down the track to measure the instrument.
In mid-July 2014, the 2 machines faced rocky ground conditions. This caused delay to the tunneling works. Special hard rock cutter discs were required to overcome the problems. The machines are scheduled to break through at Pasar Seni station at the end of October 2014. Located at a popular tourist area, the Pasar Seni station footprint includes the structures of UO Superstore, Plaza Warisan and Klang bus terminal. Demolition of these 3 buildings took 6 months to complete. Construction of the station box was done in stages. starting with the construction of the diaphragm walls at the Klang bus terminal site. King posts were then piled and temporary struts were installed to support the completed diaphragm wall. Using a semi-top-down and bottom-up construction method, the concourse level is first constructed concurrently with the demolition of the basements. With the concourse slab in place, construction of the roof slab began. On Jalan Tun HS Lee, road diversions were carried out to include the area into the construction footprint. 132 kilowatt cables located beneath the road were boxed and protected to allow excavation beneath it. The base slab on the north side of the station is 50% completed, in preparation for the first TBM from Semantan to breakthrough at the end of October 2014. The Merdeka Station construction area measures 1.85 acres. Work on site started in April 2012. Diaphragm wall construction for the station box was completed in early 2013. King posts were installed together with a temporary strutting system. 4,000 tons of steel was used to form 6 layers of struts that spans across the 32-meter deep station box in a top-down construction method. At the final excavation level, subsoil pipes were installed to channel groundwater out. As a safety measure, lightning protection cables were installed to channel lightning discharge to the ground. Base slab construction for the platform level was completed by end of April 2014. Once the platform level was completed, the lowest level of struts were removed. This station consists of 4 levels in total: platform, plant room, lower concourse and upper concourse levels. Once the struts were removed, the construction of the plant room level began. A load-bearing tower scaffolding was used to support the construction. The slab was constructed in 7 panels and was completed by the end of August 2014. As the slab was completed, the next level of struts were removed and the construction of the lower concourse level began. The TBM from Pudu shaft is expected to break through here at the end of September 2014. The Pudu launch shaft is another launching site for another earth pressure balance TBM. This is also an escape shaft for the line. Preparatory works, including diaphragm wall construction, began in July 2012. The roof slab was constructed with 2 excess openings to allow work to proceed downwards. Using the top-down construction method, 4 levels are being constructed under the roof slab. The TBM arrived on site in February 2014 and assembly began 1 month later. Lowering the TBM through the tight roof opening was a massive challenge.
For our shaft at Pudu here, we have to work backwards in a sense. So the conventional way is that we can lower the middle, the front and the tail. Okay. So in our case in Pudu, we have to do it opposite. We lower the tail, the screw conveyor, the middle, the front, followed by the front shield.
The TBM started mining on 5th May 2014 towards the Merdeka station. The site is being prepared to receive 2 TBMs in October 2014.
What you see right here is in the midst of hacking the rebar for the tunnel eye. And once we have done with that, we'll be waiting for the machine from Inai to arrive to break through into our shaft.
The Bukit Bintang station is at the junction of Jalan Bukit Bintang and Jalan Sultan Ismail. The construction of the station box is being done in stages to ensure traffic flow is not disrupted. During the first stage, the road was realigned to allow the construction of 1/2 of the station box. Diaphragm walls were constructed, king posts installed, and strutting was carried out. A top-down construction method was used. soil was excavated to just below the roof slab level. Then the roof slab was constructed. Once completed, struts were removed and geofoam blocks were used to fill the void. The site was backfilled and covered. A road was constructed above to allow realignment of the traffic, and the second stage of the station box construction. The diaphragm walls were completed, but the excavation of the site below the roof slab is currently ongoing. In August 2014, the lower TBM passed under the station box, followed by the second TBM 1 month later. The site parameters of the Bukit Bintang station has been extended to include a larger underground subway link. A briefing session was held to inform the stakeholders involved on the new traffic management plan.
We call it subway. The subway, now we have acquired the work area by doing the traffic diversion. The traffic diversion, we call it phase 1. We have a total for this subway construction 5 phases. And we have completed the utility relocation. And now we have started the diaphragm wall.
The Inai launch shaft is located beside the Pasar Rakyat station. The circular shaft was constructed using secant board piling. It was excavated to a depth of 34 meters. Chambers were dug for the assembly of the variable density TBM. The TBM arrived on site in October 2013 and took 6 weeks to assemble. The TBM began mining in December 2013 towards the Pudu shaft and is expected to arrive in October 2014. The Pasar Rakyat or Tun Razak Exchange Station is located at the junction of Jalan Tun Razak and Jalan Kampung Pandan, right beside the Tun Razak Exchange. The station box is the largest and deepest and will connect with future KV MRT lines. The walls were constructed using secant board piling. Controlled rock blasting together with a surface miner was used to excavate the station to a depth of 45 meters. In November 2013, the lower variable density TBM from Cochrane passed through the unexcavated section of the station box. On 9th of January 2014, the first variable density TBM broke through from the Cochrane site. The TBM had completed its drive and was dismantled. Excavation continued with controlled rock blasting to remove the unexcavated section and tunnel lining of the lower TBM. As of the end of September 2014, 90% of the excavation works were completed. An ongoing challenge at the Tun Razak Exchange was seepage of groundwater into the station box.
Initially, the water ingress is quite minor, and then we are able to control it, but it actually become worse. And then it actually flooded the whole job site, and we have to mobilize additional pump. So by 3 pumps all together working overnight, it actually managed to control it.
Cavities also appeared in the station box.
The danger here is that we cannot leave this cavity exposed, because one is that we'll have the chances of more water ingressing into the shaft. Number 2 is that it's a potential hazard for people working around here. We have a lot of loose boulders that's hanging there. We need to secure this cavity first before we can go down further down or do any other further work. So it is a potential hazard and danger.
Construction of the base slab started in March 2014 and is currently ongoing. The Cochrane Station site has the largest construction footprint, which measures about 14 acres. Work started on site in May 2012. Secant board piling was used to build the retaining walls. Once completed, controlled rock blasting was employed to excavate the shaft down to a depth of 30 meters. The first variable density TBM arrived on site in early February 2013 and was launched by the Prime Minister of Malaysia, Dato Sri Najib Tun Razak, on 30th May 2013. The second variable density TBM began mining in July. Both the first and second TBMs were mining towards Pasar Rakyat. Two more variable density TBMs were assembled and launched in October and November 2013 respectively and were mining towards Maluri. The TBMs mining towards Pasar Rakyat or the Tun Razak Exchange were initially mining in a parallel configuration, but after 400 meters, it changed into a stacked configuration. The first TBM mined below Pasar Rakyat towards Bukit Bintang and was fed with segments and slurry from Cochrane. But after passing the Inai shaft, the TBM feed was disconnected and was supplied with materials from the Inai shaft. Under Jalan Bukit Bintang, in front of the LT80 building, the TBM faced problems with a screw conveyor. The machine was halted for a few days for repair work.
The machine has a prolonged stoppage here for about 2 to 3 days. As we know, every prolonged stoppage is a risk to settlement. There may be connection between the TBM and the surface.
Two sinkholes occurred over a period of a week.
With a prolonged stoppage, it might have been disturbed and we were not able to mine forward and grout the area, so this could have caused a sinkhole.
A comprehensive traffic management program was put in place and remedial works were carried out immediately. The first 2 kilometers of the tunnel drive from Cochrane was carried out in KL karstic limestone ground conditions. Just before reaching the Pavilion Mall on Jalan Bukit Bintang, the ground conditions changed to the Kenny Hill Formation, which is more stable. The variable density TBM underwent a mode conversion from a slurry-based machine to a dry muck mode.
For the past few months, this variable density machine is taking out material from the machine using pipelines. So the difference between this and what we are going to do, which is an earth pressure balance machine, is we are changing it from, instead of using pipes, we are taking out the material using conveyor belts.
The slurrifier box and slurry pipes, which are components in a slurry mode machine, were taken out. A conveyor belt was installed for the dry muck mode.
This is the conveyor belt, so that it can convert into earth pressure balance. So this conveyor belt transports the material from the front into the back of the tunnel boring machine, and then it will be transported out using a train.
After the conversion, the TBM faced another challenge. It encountered ground anchors left from the construction of the Pavilion Mall. Frequent intervention stops were required.
So in the morning, actually, we found some ground anchors dropped underneath the conveyor belt, and we decided to stop the TBM and go for intervention, look for the ground anchors, cut it and remove it.
The TBM had successfully passed under the Bukit Bintang station and is expected to break through at the Pudu shaft in October 2014. Meanwhile, in the tunnel from Cochrane, tunnel-based concreting was carried out and has been completed for all 4 tunnels, 2 to Maluri and 2 to Pasar Rakyat. At the Cochrane site, there are 4 levels: the platform, concourse, lower plant room and upper plant room. All the levels have been completed and the roof slab is currently being cast. Located in Cheras, the Maluri MRT station and the integral crossover box measures 9.14 acres. Due to its location at a busy dual carriageway, the station box construction is done in stages. Secant board piling was used to construct the perimeter of the station box. Once strutting was completed, temporary road decks were put into place to allow the traffic to be realigned and construction of the other parts of the station box could be completed. Excavation works of up to 21 meters is being carried out using controlled rock blasting and is expected to be completed by November 2014. Extreme care and planning is required, and the road is temporarily diverted during the blasting. 2 TBMs from Cochrane passed under the station box in December 2013 and February 2014. The tunnel lining was later removed, also by blasting works. The Maluri South Portal acts as the transition between the underground and the elevated section of the line. It also acts as a shaft for retrieving 2 variable density TBMs from Cochrane. Preparatory works began on-site, followed by secant board piling. Once the portal walls at the retrieval section were completed, excavation through controlled rock blasting was carried out until it reaches a depth of 15 meters. Strutting works were carried out, followed by excavation works. Structural works are also ongoing. On 8th and 24th April 2014, both southbound TBMs mining from Cochrane broke through here. This marked 50% of the tunneling progress.
We've brought the underground work to a very good pace, and today with this breakthrough at Maluri South Portal, I think it's testimony to all the hard work that has been put in by the team.
This is the last breakthrough for TBMs operating in the slurry mode.
I have never worked with such a versatile machine, which is basically able to handle most of the ground conditions what we can throw at it. So it is an extremely good machine for variable ground conditions. Let it be karst or mixed phase conditions or whatever, this machine will be able to handle it. So it's a very versatile system.
After the breakthrough, both TBMs were dismantled and retrieved. Excavation and construction works for the base slab was completed by the end of September 2014. At the end of October 2014, the progress of the underground works for the KV MRT has reached 70%, which is on target. All teams from MMC Gamuda KV MRT are working closely together to attain the highest standards and best engineering design.